So recording is started. Hopefully, give me a confirmation. My screen is visible to each one of you, and my voice is clearly audible to each one of you. Just give me a thumbs up, or you can unmute and tell me. My screen is visible and my voice is clearly audible.
Yes, sir.
Okay, great. So, great to go. So,
Okay, sir.
last time we are there somewhere. Okay, last time we are here, and I think we have done the classification, and we came to this point, working of the reciprocating compressor. Okay, so there are in the last lecture we have make a list of the different component, and let's have a revision of that component associated with the construction of the compressor. And today we will see for the working of the compressor, and then we'll move for the last point, that is numericals. Okay, so few components of reciprocating compressor are: first one is the cylinder, second one is the piston, third one is the connecting rod, fourth one is the crank, and last one is the crankshaft. My question to each one of you is: piston is subjected to which motion? Piston is subjected to which type of the motion?
In cylinder.
Yes, which type of the motion?
Reciprocating.
Perfectly correct. Connecting rod is subjected to which type of the motion?
Oscillatory.
Perfectly correct. Crank is subjected to which type of the motion?
Rotatory.
Yes, very good. Rotary motion. Very good. And the cylinder is stationary one. Okay. So this cylinder and the crankcase is the one part. Okay. So as far as this terminology, its working is same as that of the IC engine, internal combustion engine of our two-wheelers and four-wheelers. Okay. So this piston has maximum position over here somewhere. That position is called as a top dead center. It is known as a top dead center. It is called as a TDC. And once it come down, there is a one fixed position of that cylinder so that it can come down maximum that particular point. So that point is called as a BDC, that is bottom dead center. One is a top dead center, maximum reach of the piston, and one is a bottom dead center, maximum minimum rest of the center. Okay. So as this piston is continuously reciprocating inside this cylinder, it is reciprocating in between the TDC to BDC, top dead center to bottom dead center. Okay. Now what happened? What about its working? Its working is like, when I'm telling you that the piston is reciprocating inside the cylinder from TDC to BDC, you can see over here, it goes up to that point and it goes up to somewhere here, BDC. So again, I'm telling you the piston is reciprocating inside the cylinder from TDC to BDC and from BDC to TDC. There are two valves at the head of the cylinder. There are two valves at the head of the cylinder. One is the inlet valve and one is the exhaust valve, or it can also known as the suction valve and delivery valve. This is the suction valve and this is the delivery valve. Suction port or delivery port. Okay. Now, when this piston is at top dead center and when it comes down, because of the vacuum created inside the cylinder, low pressure, the inlet valve opens up and the exhaust valve is closed. Whatever the amount of air,
Sir, some
yes,
people are waiting outside.
okay, let me, actually auto admit is already activated. There is nobody. Sir, आवाज इतना ही रोहिणी आहे. Now am I audible to each one of you? Rohini Aher.
Yes, sir.
Rohini Aher. Everybody, am I audible to each one of you, no?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Sir, please send attendance link. Okay, at the end of session, I will send. Okay, okay. So let me focus on the explanation, then I'll give whatever the required things to you. Okay. So, coming back to the point, piston is subjected to which motion? Piston is subjected to which type of the motion? Piston is
Rotary.
subject to piston.
Reciprocating.
Perfectly correct. So, piston is piston is in reciprocating motion. It moves in between. If it is at top, what does that name? It is at the top, so it moves from top to bottom. So, top means what? Top position means what? It is top dead center. What is that? Top dead center. Okay, so maximum lift of the piston is a top dead center. Once it come down, so it is a bottom dead center. What are the two different positions of the piston in between that? It is a reciprocating. One is a top dead center, and second one is a bottom dead center. Which are the two positions? Which are the two positions? Hello, am I audible to each one of you? Hello.
Yes, sir.
Which
Yes,
are the
sir.
two positions? Which are
Yes, sir.
which are the two positions of the piston are there? One is a top dead center and one is a bottom dead center. Which are the positions? Which are the two different positions? Which are the two different
Top
positions?
dead center and bottom dead center.
And they are known as a TDC and BDC. Okay. Okay. Now these are the two different valves. One is a suction valve and the second one is a delivery valve or exhaust valve. Okay. When the piston is moving from TDC to BDC, when the piston is moving from TDC to BDC, at that time, this inlet valve is open and exhaust valve is closed. Try to understand the conditions when the piston is moving from TDC to BDC, the inlet valve is open and exhaust valve is closed. Okay. Why this is? This is because of the vacuum created inside the cylinder. Okay. When the piston is moving from TDC to BDC, the vacuum is created inside the cylinder. Because of the pressure difference, the inlet valve is open and the exhaust valve is closed. Okay. When it moves from TDC to BDC, your crank rotate to 180 degree. Your crank rotate to 180 degree. I'm repeating, try to understand. Once piston is moved from TDC to BDC, at that time the vacuum is created inside the cylinder. Because of the pressure difference, the inlet valve is open and whatever the air present outside, it comes and trap into the cylinders. At that time, the crankshaft rotate through 180 degree. Give me the answer of my questions. You are audible. Huh? When piston is moving from TDC to BDC, which valve is open? Inlet valve or exhaust valve?
Elect
Inlet.
Very good. And your crank rotate through how much degree?
180 degree.
Perfectly correct. Perfectly correct. Nice. Okay. Perfectly correct. Now it comes to BDC and your inlet valve, say your crank is over here somewhere. Now, when the piston moves from BDC to TDC, when piston moves from BDC to TDC, means piston is moving upward direction. Okay. TDC to BDC stands for piston moving from downward position. Now piston is moving from BDC to TDC means piston is moving upward. When piston is moving from BDC to TDC, your crank rotate through 180 degree and at that time your inlet valve is closed and due to high pressure inside the cylinder, the exhaust valve is or discharge valve is open. Okay. My next question to each one of you: when piston moves from BDC to TDC, your crank rotated through how much degree?
180.
Perfectly correct. 180 degree. So in that case, which valve is open? Exhaust valve or inlet valve?
Exhaust valve.
Exhaust.
Exhaust valve is open. It is because of the high pressure inside the cylinder. As the pressure inside the cylinder is more, or air pressure inside the cylinder is more, it releases outside of the system and the air is trapped in the air receiver, and your air compressor tanks store the high pressure air for the further application. So what are the different technical terms that you have to remember? The technical terms you have to remember in case of the working of the reciprocating compressor are piston movement, that is TDC to BDC and BDC to TDC. Second one is a crank rotation, 180 degree. Once crank rotated through 180 degree, piston moves from TDC to BDC. Next 180 degree, crank rotated through BDC to TDC. Which valve is open when piston moves from TDC to BDC? Inlet valve open. Which valve open when piston moves from BDC to TDC? Exhaust valve. So these are the things that you have to remember, and this is very simple working of your reciprocating compressor. Okay. Now we have to move for the numericals. But before going to the numericals, let me know, everybody understood the working and the different components of the reciprocating compressor? If yes,
Yes.
okay, great. Only one answer. Huh?
Yes, sir.
Okay, great. Give me a thumbs up if everybody understood. I'm expecting more responses because we are 39. Those who don't wish to unmute themselves, you can give me a thumbs up in the chat box. Okay, great. So let's move towards the very important part. Thank you. Let's move towards the very important part, that is the numerical. Okay. But he has entered just now. So numerical based on thermal power plant. So based on the thermal power plant, please give me a quick revision about what are the different components are there in the thermal power plant. I'll start and you have to tell me the others. Huh? First part is a boiler. Second part is
Superheater.
Generator.
super heater. Okay, steam boiler, then super heater. Then next is a
Steam turbine.
steam turbine. Very good. Then steam turbine.
Generator.
Steam turbine.
Generator.
Very good. Steam turbine is connected to generator. Water is connected. Steam is coming out from the turbine is given to the.
Condenser.
Very good. Then condenser is connected to. Condenser is connected to water tank. Then water tank is connected to pump and it is again recirculated. Very good. Perfect. Now, my first question to each one of you is, what is the input given to the power plant? Which form of the energy is given to the
Heat.
heat energy? Perfectly correct. So heat energy is given to the power plant. Very good. Perfectly correct. What is the output of the power plant, thermal power plant?
Steam.
Output of the power plant from steam.
Electrical.
No, that is the another part. Before electrical energy, what we get?
Mechanical energy.
Perfectly correct. So in case of thermal power plant, our input energy is heat. That is in the boiler. And our output energy is there in the turbine mechanical. Okay. So moving towards this, if boiler is there, boiler is responsible for the development of heat. So can I say ki we are giving some fuel to the boiler? Let me do this. We have to give some fuel to the boiler, no? So what is the input? Fuel. Fuel is given to the boiler. Fuel is given to the. So fuel produces the energy. So how much amount of the energy produced by the fuel? That is the question. So energy of the fuel is nothing but its calorific value. energy produced by the fuel is nothing but its calorific value. Means MF fuel has its fuel contain energy. Fuel contain energy, and it is related with its calorific value. Calorific value. Clear? Then next, next talking about turbine. Turbine, what is the output of turbine? Mechanical energy. Mechanical energy. Okay. So talking about this fuel. So say mechanical, I'm talking about the mechanical energy. Say I'm representing MF as a mass of fuel. Okay. And I'm representing CV as its calorific value. CV as its calorific value. MF means what? Mass of fuel. Okay. And CVA, I'm going to give CV as calorific value. Calorific value. Okay. Now if I consume 1 kg of fuel, if I consume 1 kg of fuel, means if MF is equals to 1 kg and say CV is equals to 2000 kilojoule per kg, say for example. So what does that means? I'm repeating. Boiler, the energy developed inside the boiler is because of fuel in the combustion chamber. Fuel has calorific value. Okay. Now, MF is mass of fuel, CV is the calorific value. If say 1 kg of fuel I burn in a boiler, that has the calorific value say 2000 kilojoule per kg. So, how much amount of the energy developed by this system, or say power, how much amount of the energy given by that combustion of fuel is nothing but MF into CV. Are you getting this? जर एखाद्या बॉयलर मध्ये तुम्ही 1 किलो फ्यूल बर्न करत आहात, इफ यू आर बर्निंग, अगर आप लोग किसी बॉयलर में 1 केजी इतना फ्यूल बर्न कर रहे हो और उसका कैलोरीफिक वैल्यू अगर 2000 है, तो वो कितना पावर डिलीवर कर रहा है और कितना एनर्जी सप्लाई कर रहा है? तो एमएफ इंटू सीवी इतना एनर्जी लिबरेट कर रहा है. ठीक है, इतना क्लियर है? देन मैं टर्बाइन की बात करता हूं. टर्बाइन में मैकेनिकल एनर्जी होता है. ठीक है, तो मैकेनिकल एनर्जी आउटपुट जो होता है, तो इट इज नथिंग बट पावर, एंड दैट इज, हम लोग उसको बोलेंगे पीओ. पावर कैसे निकालते हैं? अगर मुझे उसका टॉर्क पता है, इफ आई नो द टॉर्क, so in that case I can easily identify the value for PO, that is PO is equals to 2 pi into N into T upon 60. Sometimes turbine power is mostly, it is given, P output is mostly given to us, and boiler energy we have to calculate. So I guess each one of you is now understood how much amount of the energy is given to, we can, if the amount of fuel is given to you and the calorific value is given to you, you can easily identify the amount of energy developed inside the boiler. Am I right? Am I right? Am I audible to each one of you?
Yes, sir.
जर मी तुम्हाला
Yes, sir.
सांगितलं की माझ्याकडे 1 लिटर पेट्रोल आहे आणि त्याची कॅलोरीफिक व्हॅल्यू 10,000 आहे, तर जर मी त्या 1 लिटर पेट्रोलला बर्न केलं तर किती एनर्जी लिबरेट होईल? तुम्ही कसं कॅल्क्युलेट करणार? मास ऑफ फ्यूल इंटू देअर कॅलोरीफिक व्हॅल्यू, एमएफ इंटू सीबी. सिंपल. क्लियर आहे? क्लियर आहे इच वन ऑफ यू? सर्वांना समजतंय का मी काय बोलतो? दॅट इज इम्पॉर्टंट पार्ट.
Yes, sir.
Okay, great. Good to go. Then next, let us see and let us look for the numerical. And we have a few basic formulas, but That this is very important. See, thermal power plant. So the efficiency or the thermal power plant, we have to calculate the thermal efficiency of that power plant. So performance of any power plant is measured on its efficiency. Efficiency is nothing but output upon input. So what is output? Output is nothing but RPM of or power developed by the power plant, power output. What is input? Just right now you have calculated. Heat energy is given to the boiler is power input, and efficiency is always calculated in terms of percentage. So it is, sorry, it is 100 multiplied by 100. So performance, in order to calculate the performance of power plant, we have to calculate its efficiency, and the formula to calculate the thermal efficiency of the power plant is nothing but output power upon input power into 100, as it is calculated in terms of percentage. Okay, right now I told you input power is equals to mass flow rate, that is MF into CB. But when we are calculating this, we have to focus on the consumption of fuel in terms of kg per second, and the calorific value is in joules per kg, MF into CB. Now there is there is simple conversion, unit conversion is there. Yes, is there anybody saying something? No. So mass flow rate. So we are talking about the power plant. Okay. So the consumption of fuel is in tons. Power plant consume fuel in tons. Okay. So in some cases, the consumptions of fuel in ton per day is given. In some cases, consumption of fuel in ton per hour is given. So we have to convert. We require mass of fuel in kg per second. Okay. So how to convert that? So 1 ton corresponds to 10 cube kg. So 1 ton into 10 cube, so it is kg. We required in seconds, so 1 day consists of 24 hours by 60 minutes by 60 seconds. So that will be kg per second. And if it is given in terms of hours, so in that case, we'll be just roaming that 24 hours because it is already given in terms of hours. So 60 into 60. So once we conduct numerical, this thing will be much clearer to each one of you. Okay. Power is 2 pi nt upon 60. I told you. Let us start with the simple numerical. Just have a note down of this numerical. You can have a note down, or I'll give you the recording session, no issue, but focus on the numerical. Okay. The first numerical so far. Coal consumption of thermal power plant is 100 ton of coal per day. So what is given to me? That we have to write down. Coal consumptions of the thermal power plant is 100 ton of the coal per day. The calorific value of the coal is 21,000 kilojoule per kg. If power generation in a 1 day is 500 kilowatt or 5,000 kilowatt, find overall efficiency of the power plant. Okay, so what are the different things? Somebody's, oh my god, so many people are waiting. Okay, sir, there is a joining problem. Many students are trying to join the meeting. Now all are connected. Ayush Tungarwal.
Yes, sir.
Okay, great. So good to go. I'm repeating the questions. Try to understand the question. The coal consumption of a thermal power plant is 100 ton of the coal per day. So 100 ton per day. So what is given to us? We are going to separate out the given terms. What is given to us? 100 ton of the coal per day means mass of the fuel is given to us. So MF is given to us. Mass of the fuel is equals to 100 ton per day. 100 ton per day. This is given to us. Then second, the calorific value means CV is given to us. Calorific value of the coal is 21,000 kilojoule per kg. This is given to us. if the power generation in one day is, if the power generation in one day is 5,000 kilowatt. So what is given to us? This is the capacity of the power plant to produce the power. So it is the output. PO is given to, that is 5,000 kilowatt. Okay. Find overall efficiency of the power plant. So I guess what are the different given content? Each one of you is understood. Okay. So what is given to you? That is there in front of you. To find what is to be identified. So the thing which is to be identified is we call find overall efficiency. So they asked me to identify efficiency. I have the formula for efficiency where symbol for efficiency required. A symbol for efficiency. They told me to find out the efficiency, or we can say overall efficiency. For overall efficiency, you can write eta or you can write eta O is equals to. Now, I guess given data is clear to each one of you. I guess given data is clear to each one of you and to find is clear to each one of you. Okay, इथपर्यंत कोणाला काही इश्यू आहेत का? Yes or no? Give fast. No. Okay, great. Only one response.
No, sir.
No, sir.
Okay, good.
No, sir.
Great. So let me duplicate the slide. So now, till you don't have any issues. Okay. Come on, this. Okay. Now, if I wish to calculate its solution, what to do? What is the formula to calculate the efficiency? The formula to calculate the efficiency is output upon input. So we know what we know. We know that what we know the formula. What is the formula? Eta is equals to, that is efficiency is equals to efficiency of the thermal power plant is equals to efficiency of the power plant is equals to output upon input. So what is our agenda to calculate efficiency? So we must know the P output.
Input.
P output and P input. Sorry. So P output is already given to us and P input is to be identified. So P input is equals to, oh, but that is the question. So how to find out P input? Just right now I told you, in order to calculate the input power given to the thermal power plant is heat. And how to calculate the heat? The formula to calculate input power is MF, mass of the fuel, into its calorific value. Okay, so what is mass of fuel? The mass of fuel is 100. It is 100 ton per day. But we don't want this in per day. We want this kg per. We want this in kg per seconds. So mass of fuel is given to me is 100 ton per day. So how to convert? Just right now I told you how to calculate or how to turn the consumptions of fuel if it is ton per day. How to convert it into kg per second. So 1 ton stands for 1000 kg. So 100 ton stands for 100 into 10 raised to 3. It is kg. It is in kg. And 1 day means how much second? 1 day consists of 24 hours.
24 hours.
1 hour consists of 60 seconds.
16 minutes.
60 minutes. And 60 minutes consists of 60 seconds. So whatever the answer coming out, it is nothing but kg per. Okay.
Second.
Whatever the answer that you have to tell me. Now CV. The value for CV is,
Sir,
Yes, tell me.
इफिशियन्सी आहे ना तिथं मल्टिप्लाय बाय 10 100 राहिले
करू ना आपण पुढे ऍट द एंड ऑफ ते करू आपण, डोंट वरी. You can write down over here, no issue. You can go and multiply at the end, no issue. Okay. So the next is CB. So CB is given in terms of 21,000 kilojoule per kg. But we want it is in joules per. We want it joule per kg. So kilojoules. So we have to multiply these things with the given quantity.
1,000.
1,000 or 10 cube. Very good. So it is equals to 21 into 10 cube joules per kg. So how much this is? Whatever the terms comes out, we have to put it over here. We know the CB. Now we have to calculate the value for. Let me clear this. Copy paste. Okay. So once we know MF, once we know CB, you have to tell me this answer. No? You have to tell me this answer. Okay. And you have to calculate and you have to tell me the. Everybody, please go ahead and calculate the P input, power input given to system. Everybody, please go ahead and give me mass of fuel first. MF is equals to how much? Then multiply MF into CB. Then tell me the. Each one of you, please tell me. You have to calculate the things. I have a calculator with me. Let me put the values. Let me check. I have a calculator. Please, everybody, go ahead and calculate the things. I have the calculator, and the answer for me is 100 into 10 cube divided by 24 into 60 into 68 is 1.1574. My answer is 1.1574 kilojoule per second, kg per second. And let me calculate the value for power input is 1.1574 into 21000. The answer, my answer is 1.574 into 21000 into 10 cube. The answer is 24.3054 into 10 raised to 6 into 10 raised to 6. It is my answer, and the unit for it is W, that is watt. So these are my answers. Everybody, please, you have to do it by yourself and check whether my answers are right or wrong. So we have power input, and already in the numerical, power output is given to us, that is 5000 kilowatt. And that is 5000 kilowatt output is given to us. So 5000 kilowatt means 5000 into 10 cube watt. So we have power input, we have a power output, and if I wish to calculate the efficiency, let me put my formula again over here. Let therefore equals to you have to take the ratio power output upon power input. Please go ahead, help me with these calculations. Everybody, power output divided by power input. So each one of you has to tell me the answer. No? Okay. 5010 cube divided by 24 into something into. So I have the answer for this is in 200. Now we can multiply over here by 100. But it is efficiency is always in percentage. And let me put into 100. So can anybody tell me the answer? I have the calculator, but sir, there is a joining problem. Many should. Okay, done. Ayush, can anybody tell me the answer for this?
20.5%.
20.5%. So the answer for it is 20. My answer is 20.571. Okay, I'll go with you. Very good. Who is there? Tell me your name.
Kiran Raut, sir.
20.5%.
Very good, very good. 20.5% is the right answer. Kiran Rao and someone is there, na?
Aveshik.
Aveshik. Very good, Aveshik. So the efficiency is equals to 20.5%. Very good. Nice. Okay. This is our answer. This is our answer. Let us have an overlook of this. What they asked me, they told me to find the efficiency. And I have calculated the efficiency. It is easy or not? Only you have to pick,
Yes, sir.
if you just you know the power input and if you know the power output, and if you know simple formula efficiency is equals to power input upon output, you can easily identify the answer. Okay. So shall I go for the next numerical? If anybody is having any doubt here with this, please ask me. If no, then give me a thumbs up or unmute yourself and tell me so that I'll start next numerical. Shall I go for next numerical or anybody is having any doubt, query? Kiran out, very good, Kiran. Okay. Anyone? Only Kiran and Sheikh. Ankit, Rahul, Kashid, okay. Pawan, okay. Saili Domse, okay. Bhosle, Pooja Bhosle. Where is she? She's not there. Okay, good. So let's go for the next numerical. The same type of the numerical. A steam power plant. Right now you have to tell me directly the things. A steam power plant has coal consumption. So what is given to me? This is what? 165 per hour. It is what?
MF.
Very good, nice. It is MF is given to me. Very good. I'm directly taking the given data. MF is given to me. Number one, MF is given to me.
CV equals to 500.
Then calorific value, CV second parameter is given to me, that is 3500 kilocalorie. Now here it is given in terms of kilocalorie. Yeah? Kilocalorie, let me put it, copy and put it over here, kilocalorie per kg. Now if the power generation is 250 megawatt, if the power generation is 250 megawatts, so what is given to me? Power generation. Power means what? Generation. Power generation. Power generation means what? What is 250?
PO.
Yes, power output. Perfectly correct. Who is there?
Aveshik.
Aveshek. Very good. Power output is given to you. Power output is given to you. 250 megawatt. Very good. And find overall efficiency and take 1 kilocalorie is equals to, this is also given. Copy. Fourth part is given to me, that is, let me, yes. My screen is visible, na? It's visible to each one of you, na?
Yes, sir.
Yes, sir.
Good. To find, so to find, they told me to put, find overall efficiency. So it is to be, they told me to find out the efficiency. efficiency is equals to question mark.
P0 upon P.
Perfectly same. P0 upon, let me put out the solution over here. Simple, very good. Solution. So what is the formula? The formula is
Eta equals to P0 upon Pi.
perfectly correct. It is P0, P output, P output upon P input, and it is 100 as it is in percentage, no issue. Okay, so then it is equals to. So P output, do we have P output? Yes, we do have output over here. P output we have, and P input is not given to me. So my first target is to calculate PI. How to calculate PI? Can anybody tell me? What is the formula to calculate PI?
MF into CV.
Perfectly correct. Very good. Nice. MF into CV. So MF is equals to how much? MF is equals to, let us name.
165
So MF is equals to MF. How to calculate MF? How much MF is given to me? It is 165 ton per hour. So let me copy paste it. It is MF is copy. So here 165 ton per hour is given to you. Please tell me how much kg per second it is. Units conversion. Let me check who is the first. Who will tell me the answer? MF is equals to 165 ton per hour. So how much kg per second? How to convert this?
1.9097.
No. 165 ton means 165 into 10 cube kg. Okay.
Yes, sir.
And 1 hour, this is hour. So 1 hour stands for how much second? 60 into 60. So 165 into 10 cube divided by 3600 second. Simple, no? 165 ton. So it is 165 into 10 cube divided by it is in hour. So hour means 1 hour. So 1 into 60 into 60. So it is equals to, tell me.
45.83.
Perfectly correct. It is 45.833 kg per second. Who is there?
Gayatri Jadhav.
Very good. Nice. So right now I have a fuel that is kg per second. Now I want this CV. So CV is where is CV? Oh, I have not written CV over here. CV is equals to 35. Now look at here. CV it is given in kilocalorie per kg, but we don't want this in kilocalorie per kg. We want it is in kilojoule per or joule per kg. So how to convert? So here it is given that kilocalorie, 1 calorie is equals to 1 kilocalorie is equals to 4.18. So I have to make a copy it, duplicate slide. Okay. Sorry. Now CV. CV it is given to me, it is 3500 kilocalorie per kg given to me. But I don't want that in kilocalorie per kg. I want it is in kilojoule per kg. So 1 kilocalorie corresponds to, look at here, 1 kilocalorie is equals to 4.18 kilojoules. So it is 3500 into, I want to convert kilocalorie into kilojoules. So into how much? Into how much?
4.18.
Perfectly correct. 4.18. So whatever the answer it is coming, it is in kilojoule per kg. Okay, so I want that answer into the joule joule per kg. So whatever the answer coming out, it should be, it is in 10 raised to 3. So tell me this, P500 into 4.1, it is equals to how much?
14630.
How much?
14630.
Perfectly correct. 14630 is a kilojoules.
14 sir.
Okay,
मी 5 केलाय.
14. Okay, very good. 14630 is a kilojoule per kg. But I want that into joules. So kilojoules has to be converted into joule. So it is 14630 into 10 cube joule per kg. Now I have answer of MF. It is 45 point something. I have answer of CV, that is 14 something, 146 1463 MF into CV. So can I have answer for this? PI, input power. Please go ahead,
Yes,
calculate
sir.
the value of PI and tell me the answer.
6.7 10 to 5 kg.
How much? 6.7.
7 into 10 raised to 5.
Okay, I have 6.70 point
536.
54 into 10 raised to 10 raised to how much? 10 raised to how much?
Sir, 5 sir. 6.754 into 10 raised to 5.
6.7.
54.
Hold a second, no, hold a second. Let me erase this answer. MF into CV is equals to, now tell me,
705
6.705
into
into
10 raised to 5.
10 raised to 5. Is it right
Yes,
answer? Is it right answer? Please check it out. I have something different answer. Please everybody try to calculate and tell me the answer. Let me calculate. 45.833 into 14630 into 10 raised to 3. I have different answer. Please tell me the right answer. So, beta, it is something is missing over there. Huh? Please recalculate the answer. Please recalculate the answer.
6.72.
Somebody is telling. Please loudly. 6. Please, somebody is there.
67.04 into 10 की power 5.
0.7053.
कौन बोलता है? Somebody is there.
67.
67.
Point
हाँ
04
हाँ.
into 10 की power 5.
No. हाँ
6.7.
Sir,
6.7.
05
हाँ
05 10 raised to 8.
हाँ. See, you are something missing somewhere there. Let me on calculator. See, calculator. Now tell me, what is your
67.1 into 10 की power 5.
45.833 ना 0.833 into what? 146. You can see my calculator, na?
Yes, sir.
Yes, sir.
Yes sir.
14630 into 10 raised to 3 into 10 raised to 3 कहाँ से डालूं अभी इधर? Raised to 3 means 1000 ना? This is answer. So if you press engineering, where is engineering
Sir, 10,000 हो गया.
10,000 हो गया क्या?
तुम्ही 10,000 टाकलेलं आहे.
So 10 come.
हाँ वही 0 कम हो जाएगा ऐसे सिंपल ना. तो द आंसर इज 60.
6.7.
हाँ 6.7 into I have answer
10 to
is a 670 into 10 raised to 6. यहाँ से एक डिजिट कम हो जाएगा सिर्फ, बाकी कुछ नहीं होगा. Let me clear this. So the answer with me is 670.5411 into 10 raised to 6 watt. This is the answer I have with me. इंजिनिअरिंग बटन आहे का इथे? नो. मी परत एकदा करतो. 445.833 into 14630 into 1000 ना. 1 2 3 6 पॉइंट करेंगे तो 1 2 3 4 5 6 7 8 6.7 into 10 raised to 8 या फिर 6
Yes sir.
या फिर 670.53 something into 10 raised to 6.
6.
Okay, so the answer is 670.5411 into 10 raised to 6 is the answer for power input. Now what we are going to calculate, if we have power input, now we have power output. Where is power output? Do we have power output? Yes, we do have power output over here, but it is in megawatt. So we have to convert it in watt. So how to convert megawatt into kilowatt? So let me convert it over here only. 250 megawatt is equals to 250 into 10 raised to 6 watt. Very good. So now moving towards this calculation, efficiency calculation. P output upon P input is equals to P output is how much? P output, where is P output? It is 250 into 10 raised to P. This is divided by P input is copy paste into 100. Please tell me the percentage.
3.72%.
3.72? No. No. No, I have something. See, this is 10 raised to 6, this is 10 raised to 6 is gone. This is 10 raised to 6.
37.
Yeah.
37%.
Yes, 37.283. 37.283%. Perfectly correct. Who is there?
सायली ढोमसे.
Okay, very good, Saili. So it is very easy. Okay. Very good. Nice. So if the numerical is understood by each one of you, give me a thumbs up in the chat box. Okay, Saili, this is the right answer. Give me a thumbs up in the chat box and allow me to go for the next numerical. If anybody is having any doubt, Kiri, ask me. Okay, good. Asmita, Vaishnavi, okay. Everybody understood. Nice. So next numerical for you is, तुमचं लेक्चर किती वाजता आहे? 1:35 का 31? आपल्याकडे वेळ आहे का?
135
पर्यंत आहे सर.
हा ठीक, 2 मिनिटं मी तुम्हाला न्यूमेरिकल समजून देतो आणि तुम्ही ते सॉल्व्ह करा. ठीक आहे. नेक्स्ट न्यूमेरिकल, सेम न्यूमेरिकल. स्टीम, मला त्याला फटाफट सांगा काय दिलंय. स्टीम पॉवर प्लांट हॅज कोल कन्झम्पशन इज, व्हॉट इज दिस? व्हॉट इज दिस? काय दिलंय?
CV.
A steam power plant has coal consumption.
MF.
MF.
MF. Very good. MF is given to you. Very good. First one. Simple numerical. With calorific value, हे काय दिलंय?
CV.
Very good. Very good. So CV is given to you as a then. If speed of the turbine is speed means RPM is given to you. Okay. N is equals to 1000 RPM. Okay, then and generated torque T is given. Torque is given means torque is given to you. Torque is given to it is 47 something. Don't worry about. Don't worry about the value or quantity given to you. Stick to your to find. Stick to your basics. So they ask us to find. Okay. So they told me to find out input power, output power, and efficiency. Okay. So in order to calculate efficiency, we require input and output. So let us find out the input. Input is equals to MF into CV. So MF is there, CV is there. Okay. So what changes we have to do over here? 16200 kg per hour. So we require kg per second. So it is divided by how much?
60 into 60.
Yes, perfectly correct. So MF is there, 16200 divided by 60 into 60. That is 3600. That will be your MF. CV is given to you kilojoule per kg. So we require joules per kg. So 17793.9 into 10 raised to 3. So it is
That's 3.
okay into 10 raised to 3 is required. So MF into CV. So power input is there in front of you. Okay, it is clear to each one of you. Very simple. Now, based on previous numerical, you have to calculate the input. So power input you can easily calculate. Okay. So what about power output? Power output. So power output is not given to us, but torque is given to us. So how to calculate power output? The formula to calculate the power output is P is equals to 2 pi n into T upon 60. Okay, this is the formula 2 pi n T upon 60. So 2 is numerical, pi is the 3.14, or I can put directly pi. 2 pi n is given to us, that is 1000. 2 pi n T. Torque is given to me. Torque is how much torque? Torque is this much. 2 pi n T divided by 60. That will be the power output. Okay. So P is equals to 2 pi n T upon 60. That will be the power output. And how to calculate efficiency? Once we know the power input, we know the power output, we can easily find out the value for power output. P O upon Pi is equals to efficiency. So this is the numerical for your homework, and everybody has to solve this numerical. It is a practice part, and the section is very easy for each one of you. And in the next session, I will be getting a review of this numerical, and then we'll start for the numerical on the turbine, pump, and compressor. If anybody is having any doubt, could you please ask me? And let me share the link for the attendance in the chat box. Copy. Yes, the link for the attendance is given into the chat box to each one of you. If anybody is having any doubt query, please ask me. If you don't have any doubt query, solve the given numerical and give me the answer in the next lecture. Those who don't have any doubt query, you can give the attendance and you can leave the session. If anybody is having any doubt query, you can ask me. Anybody? Okay, so far I'm getting only 26 responses. These are the 26 responses so far. 27 responses. 28. Okay. 29. So first give attendance and then you can leave the session. Hopefully you can understand the all the numericals that I have taken. Have a good day. Have a great day.